Alright class, this is a video on the quadratics review test. I'm not going to go over all the problems, I'm just going to go over just basic solutions, so not in-depth explanations for these problems. I'm going to skip numbers 1, 2, and 3. I'm going to start at, I trust that you guys can work on 5 and 6. I'm going to go over, or 4 and 5, I'm going to go over number 6. For number 6, graphing a function with the table. All you're doing is plugging in points in for x into the function, and you should get a y. This gives you a coordinate to graph it on the x and y axis. So I'm just going to go ahead and begin. So if I choose certain x's and I plug it into here. So with this, let's say if I were to choose positive 1. So positive 1, if I plug it into here, that's negative 2 squared, which is 4, and 6. So I get the coordinate 1, 6 here. If I plug in the coordinate 2, that'll be a negative 1. Negative 1 squared is 1, plus 2 is 3. So this is the coordinate 2, 3. So I plug in the coordinate 3. Plug it in, I should get a 0. So it's plus 2, which is 2. So this coordinate is 3, 2. And I'm going to do 2 more. I'm going to go for 5 and 6. If I plug in a 4, it'll be 1. So this will be 3, and this will be 6. Okay. So that's how fast I'm going to go through these. But when I have these points, graphing them on an x and y axis, 1, 6 is 1 to the right and 6 up. 2, 3, 2 to the right, 3 up. 3, 2, which is over here. 4, 3, and 5, 6. Okay, so I should get a parabola. It's facing up since my a is positive. And so that's a very brief explanation of number 6. A graph where the vertex is at the coordinates 3, 2. Okay. Alright, next one. Now we're using transformations to graph for number 7. For number 7, you have to look at what do the numbers tell you where to shift. So positive 1, that tells you to shift all the parent points 1 to the left. And negative 3, well, negative 3 tells you to shift it 3 down. Okay, so take all these points that are on the parent graph and just go, so I'm going to just draw generic points for this. So for a parabola, we have these points here. Move them all down, or to the left 1, down 3. So left 1, down 3. So here, here, here. Should get a point that is right over here. And this point is down, or to left 1, down 3. I'm thinking right over here. Okay. Alright, so very brief again. Just moving all the points to left 1 and down 3. Okay, number 8. Number 8, we're solving quadratics with square roots. With this, I'm just going to write over here. So negative 4x squared equal to negative 196. First thing you do is you have to isolate x squared. So you have to divide by negative 4. Divide by negative 4. So we're going to have x squared equal to, negative divided by negative is a positive. 4 can go into 19 4 times with a remainder of 3. And it can go into here 49 times. I'm going to take the square root of both sides. We'll have x equal to plus or minus 7. Okay, always remember that square root plus or minus. Okay, number 9. Same idea, but it's a little bit, there's really just one more step here. I'm going to subtract, or I'm going to get rid of subtracting 12, so add 12 to both sides. So we're going to have 3x squared equal to 48. Divide by 3. We're going to have x squared equal to 16. Take the square root of both sides. We're going to have x equal to plus or minus 4. Okay. Solve by factoring. X squared plus 13x minus 48 equal to 0. This has to be standard form. It already is, so that's awesome. I'm going to use the factors of 48 that whether I add or subtract them, I'm going to get 13. So with this, so 48, it may just happen where you're just listing out certain things. So let's use 2 and 24. Nope, that doesn't work. 3 and 16 doesn't work. 4 and 12 doesn't work. 6 and 8. Oh, sorry. Yeah. So 3 and 16 it does work. You have to subtract them. So with this, I'm going to write a pair of binomials equal to 0. In the first pair, we're going to have x minus 3, and the second we're going to have x plus 16. The reason that this has minus and this has plus because negative 3 plus 16 is a positive 13. By the zero product property, it states that if you're multiplying two products and there's product is 0, one or both is equal to 0, so we set both of these equal to 0. Okay, so x minus 3 equal to 0 and x plus 16 equal to 0. Right over here, I'm going to add 3 to both sides. Our solution is x equal to positive 3, and we're going to subtract 16, so we're going to have x equal to a negative 16. This means that that is where they cross the x-axis, and if I were to plug them into the original equation, this would satisfy. Okay, number 11, f of x equal to x squared. I'm going to rearrange 15 so that it's in standard, or number 11 so that's in standard form, so negative 15x plus 36. When it has this, you want to set f of x equal to 0. Okay, this means that the height of the parabola, we want it to be at 0, so it's on the x-axis, so we set this equal to 0. And it just becomes a normal factoring problem. So we're going to be using the factors of 36. Factors of 36 that we could potentially use, I believe, are 3 and 12. Yep. Okay, so we're going to have x plus 3 and times x minus 12. Oops, this should be a negative. Equal to 0. Okay, with this, if I add them together, it gives me a negative 15. And if I multiply them with positive 36, set them both equal to 0. So we're going to have x minus 3 equal to 0. And the second binomial equal to 0. We're going to add 3, so we're going to have x equal to positive 3 for our solution. And x equal to, by adding, we're going to have x equal to positive 12 for number 11. Okay, these both are our solutions. Crosses the x-axis twice at those points. Completing the square. I'm going to go ahead and write r squared minus 4r plus 1 equal to 6. When we complete the square, we want our constants all the way to the right, so I need this 1 to the other side. So I'm going to subtract, so we're going to have r squared minus 4r. I'm going to leave a blank here for now. If I subtract 1, I'm going to have 5, and leave a blank here as well. Okay, we have to introduce a new term. By completing this square, we want a binomial squared. The term that we introduce is b over 2 squared. Our b term is negative 4 in this case, because it is in standard form. So if I take negative 4 divided by 2, that's negative 2. Negative 2 squared is a positive 4. So I add 4 here, and I also have to do that to the right side. Okay, so I'm just going to erase this. We are going to rewrite this as r. What goes here is just b divided by 2. Okay, so negative 4 divided by 2, we already did this, was negative 2. The reason that we can do this is because when I square this binomial, it does give me this trinomial here. And on the right side, we're left with 9. I have to get rid of the square. Now we're solving. We're going to square root both sides. We're going to have r minus 2 equal to, square root of 9 is 3, but it's plus or minus 3. By solving, we're going to have to separate this into two cases. R minus 2 equal to a positive 3 and R minus 2 equal to a negative 3. I'm going to, in both cases, add 2 to both sides. So we have R equal to 5 for our first solution and R equal to a negative 1 for our second solution. Okay. Alright, and for the second one, it's already in standard form. So we have n squared plus 10n minus 13 equal to 0. Again, move the constant to the other side, to the right. We're going to have n squared plus 10n, leave a blank. When I move that, that becomes positive 13. Okay, here, we take this divided by 2 and square, so 10 divided by 2 is 5, squared is a positive 25. Positive 25. So we're going to have n plus 5 squared. Again, if I square this binomial, I should get this trinomial here. And over here, it is 30, 40, 38. Okay. 38. I'm going to square root both sides. So we're going to have n plus 5. Square root of 38 does not simplify, so it's irrational. But we're going to write plus or minus, 38. Plus or minus radical 38. In this case, we can't separate it because we're dealing with a radical, so we're not going to be able to simplify. So just move 5 to the other side. So I would have, if I subtract that, it would be negative 5 plus or minus radical 38. Okay, this does have two solutions, but they're irrational numbers. This form is suffices for me. Okay. All right, for the quadratic formula for number 14, we're starting out finding the vertex. The vertex is a coordinate where the It has the turning point of the parabola. It is x equal to negative b over 2a. Okay, so in this problem, the quadratic is not in standard form, so we must get into standard form. So we're going to have x squared minus 12 equal to a negative 8x. To get this to standard form, everything needs to be on one side. So I'm going to add 8x to both sides. So this, as in standard form, would be 2x squared plus 8x minus 12 equal to 0. We can find our a, b, and c. With this, our x, or b, negative b. b is 8, so negative 8 is on the numerator. A is 2, so multiply that by 2, it is a positive 4. Divide this or simplify it, it is a negative 2 for our x portion of our vertex. With this, what I do with that negative 2 is I plug it into the quadratic. So if I plug it in, I'm just going to substitute wherever I see an x here. Okay, so we always square first before we multiply, or use our exponent. So 2 squared is 4, times 2 is 8. 8 times 2 is 16, and minus 12. Okay, so 8 plus 16 is 24, minus 12 is a positive 12. So this, our vertex, is negative 2 from our x, and our function when we computed this is a positive 12. Okay, so this is our answer. That is the vertex of our parabola. It would be 2 units to the left and 12 units up. Okay. Alright, now finding our discriminants. Our discriminant I'm going to rewrite. I don't know why I erased it. Rewrite our quadratic formula. Okay, with this, our discriminant is b squared minus 4ac. I'm going to plug in b, so our b is 8. 8 squared is 64. 4 times a times c, so 4 times 2 times negative 12. Okay, this will be negative 8, and negative 8 times a negative 12. Just gotta make sure this will be 80, 16. It should be 96. So, oops, positive 96. So we're gonna have 64 plus 96. Hopefully I did that right. I think I did. So adding this, we're going to get 0, 160. Making sure that's correct. Let's see if I multiplied right. 96 plus 64. $160. Alright, I believe it is 160. I'm just not trusting myself right now. But I think that we've computed everything correctly. 24 times 2. 20. Okay, yeah, so it should be 160. Yeah, it's just kind of an odd number because this is not a rational square root. But all in all, let's remember that b squared minus 4ac is 160. Okay, so now finding the roots for number 16. So again, rewriting our quadratic equation. So again, if you do not remember this, it is negative or x equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. With this, do not forget the plus or minus. I'm seeing a lot of students drop that. Do not forget that's an essential part to this problem. But inputting this, we're going to have negative b. Our b is 8, so negative 8. Plus or minus, we're going to have b squared, which is 64, minus 4 times 2 times negative 12. And it's all over 2 times a. So with this, 2, or a is 2, so times 2 is 4. Okay. With this 64 plus, we multiplied this out. We had 12 times 8. Already did this, but I'm just going to reaffirm that this is correct. We got 64, or 96 plus 64. 0 plus 1, 160. Yeah, okay. So with this, we're going to get negative 8 plus or minus square root of 164 divided by 4. 164 can be simplified as a square root, so we have to use a factor tree. What can go into this? It could be 4 and 40. 40 can be broken up with 4 and 10. We have pairs here. Actually, 4 or 10 cannot be broken up, and it can be broken up into 2 and 5, but it will be individual numbers. So this can be broken up into -8 plus or minus. Since I can take out the 4s, it'll be 4 radical 10 divided by 4. Okay. What I could do is I could actually simplify both of these numbers at the same time. I can divide each term by 4. So we're going to have -2 plus or minus. The 4's cancel out here, right? 4 divided by 4 is nothing. Radical 10. Okay, so x equals that. These are solutions. It is irrational, but that's okay. Yeah. Alright, next one. For 17, we have to figure out for what values of c will this equation, 3x squared minus 2x plus c equals 0, will have one real solution. Okay, the only way that we would have to find the discriminant here. The only way for a discriminant to have one real solution is that this must equal 0. Okay, if it is positive, it has 2 real solutions, and if it's negative, it has no real solution. So I need to make sure, how can I get this to be one real solution? How can I make this equal to 0? So let's plug in what we know. So b squared, b is -2, so -2 squared is a positive 4, minus 4 times a, which is 3, and times c, which we do not know what it is. Okay, so let's multiply this out. So we're going to have 4 minus 12c equals 0. At this point, I'm figuring out, how can I make 4 minus 12c equal to 0? At this point, we need to figure out what can I plug in for c to make this entire left expression equal to 0. We're not quite sure, so what we can do is we can actually solve this. Just by solving for our variable here, we would subtract 4 to both sides. So I'd have -12c equal to a -4. We would divide by -12, so we're going to have c equal to -4 divided by -12 is 4 over 12. It's positive. We can simplify this to be 2 can go into both, or actually 4 can go into both, to be 1/3. Okay, so c would have to be 1/3 in order for this entire quadratic to have one real solution. Okay, so it is a fraction, but that's fine. All right, on the back side, number 18. Number 18, we want to simplify. What is I to the 23rd power? Keeping in mind that, so let's just kind of review. So I is radical -1, I squared. Well, if you square this, it's just -1. I to the 3rd power is -1. These are just properties that we've done. And I to the 4th is actually +1. So what I want to do is I want to represent this with multiples of 4. I can represent that as I to the 20th. It's the biggest number that can go into 23. Times I to the 3rd, right? We know what I to the 3rd is. All right, well this is divisible by 4, so it's going to be 1. And I to the 3rd power, just based on this, a radical -1. Well, I times it, or 1 times anything is just that anything here, so it is negative square root of -1. Okay, so this is what it simplifies to become. All right, next one for number 19. We're going to rewrite this. Radical -54 can be written as radical 54 times a -1. We know what that -1 should be. It should be I. But we're going to use a factor tree to simplify 54, or radical 54. With this, 6 and 9 can go into it. 9 can be broken up into 3 and 3. And 6 will be broken up into 2 and 3, but those are just individual numbers. So our final answer would be 3I radical 6. Because this is going inside, our i's you don't put behind, you actually put it in front, because it is a number and it's not in a radical. Alright, and for this, you do not do plus or minus because it is an imaginary number. Okay, now we are multiplying. I'm going to do this real fast, and I'll explain it at the end. Alright, so just follow along. So I'm going to multiply. Grab -10. We're going to have plus 16i. Multiply this. We're going to have positive 20i. And we're going to have -32i squared. Okay, with this we can simplify the inside, or these two middle terms. So we have -10 plus 36i, and I squared is -1, so -32 times -1 is a positive 32. we can combine these two terms here. So this will become 22 plus 36i. We put our I term, our imaginary term, on the second and our real term in the front to be in the form a plus bi. Always. Okay, so you do not switch them. Always put it in that form. Okay, 21. We're going to have 1 minus 3i. Subtract negative 3 plus 7i. Okay, so what this minus sign does is it changes everything here. So this will become plus, and this will become minus. So 1 plus 3 is 4. We're just dealing with our real integers here. And negative 3i minus 7i is a negative 10i. Okay, and that's it. You can't simplify that any further. For 22, we have 3 minus 4i plus 5 minus 6i. Okay, you can just all go ahead and add it. So we're going to have 8 minus 10i for 22. Okay. For 23, inverses, we have the function f of x equal to 2x squared plus 18. And we want to find the inverse. Well, the inverse is you switch the x and the y. This is y, but let's switch that with the x. So we're going to have x over here, and instead of x, we're going to have y over here, plus 18. And we're just solving for y, so I would move 18 to both sides. So I would actually subtract it. And then I would divide both sides by 2. So we have x minus 18 divided by 2 equal to y squared. We would take the square root of both sides. Okay. And finally, in inverse notation, and using f of x, if I put g of x, make sure you put g of x here, it will be x minus 18 divided by 2. Okay, with that, that is the inverse to this original function. Alright, for 24 here, 24. It may be hard, so when you have an inverse of a graph, you want to flip it on the line y equals x. That is this line here. Okay, we have a parabola where its vertex, it looks like the vertex is at the coordinates 0, 1. Okay, well, I can invert this coordinate. The inverse of 0, 1 is 1, 0, so that's actually right over here. So 1, 0. And the parabola, if you think of reflecting it off of this line, it would actually give you kind of a sideways graph like this. So easy trick is just maybe pick points on here and just invert them. You should get a good idea of how the inverse looks like. Okay. Alright, now we're still working with inverses, but we're using compositions to determine if they are inverses of each other. So this is kind of where we get into the tricky math sometimes. So f of x equal to x plus 9 squared, and we also have g of x, and we have radical x separate from minus 9. Okay, so to determine the inverse, I can either put g into f or f into g. All in all, if we get an x as our output, this is an inverse. They are inverses of each other. I'm going to go ahead and put this in place of x over here. Okay, so the f of g of x will be, we'll have radical x minus 9, put that in parentheses, plus 9 squared. Okay, nothing's happened to the parentheses for now, so let's drop them. What can we do with inside these parentheses is we can subtract 9 and positive 9. That cancels out, so we're just left with x squared inside of the parentheses. Well, x squares undo square roots, so we're just left with x. This is, since it is equal to x, this is an inverse. Okay, alright, next one. And if we were to do the other way, put f into g, it would still work out. Alright, let's do g of x for number 26. This will be negative 7x squared minus 4, and h of x will be radical x plus 4 divided by negative 7. Okay, I could put either or. I'm going to put h into x over here. So h into the x of g of x right in here. So it's going to put g of h of x. And I know sometimes that work can be, when you're doing the test or completing the test, is that your work can be a little bit all over the place. Make sure that you're organizing kind of in this manner using equations and proper organization here. But let's put negative 7, and in parentheses, instead of x, we're going to write h of x over here, which is radical x plus 4 divided by negative 7 squared minus 4. Okay, you cannot, do not do this. Do not cancel out right here. Okay, exponent comes first, so I'm going to have negative 7. Over here, I'm going to square both sides, or both the numerator and denominator separately. If I were to square the numerator, well, it would undo this radical. So in the numerator, we're just left with x plus 4. And if I square the denominator, well, negative 7 squared is a positive 49. Okay. With this, you might want to think of negative 7 over 1. So you could actually multiply the top, multiply the bottom. But with this, I can actually, there's a number that can go into 7 and 49. We're going to simplify here. 7 can go into both. 7 can go into negative 7, negative 1. And 7 can go into here 7 times. So if I multiply a negative 1 to everything in here, in the numerator, negative 1 times x is a negative x. Negative x minus 4, or negative x times 4 is a negative 4. All over 7 minus 4. Okay. This won't be a function. We could keep simplifying. I can make this into a 1 and then try to get common denominators here. But all in all, you will not get an x as your final answer here. Okay. So this means if you cannot simplify this to become, this one is not an inverse. Okay. Alright, so that was number 26, the home stretch. Onto the last page. I'm skipping zero product property. For 28, in completing the square of the expression x squared plus bx plus the expression b over 2 squared, we're saying that this is equal to x plus b over 2 squared. So why is this possible? Provide an example. So you could provide an example on your own. Like if I were to have like x plus 3 squared, this would actually be x squared plus 6x plus 9. And just proving by simplifying or by taking this, so by taking this, if I multiply it out, I should get this trinomial. If you were to even work out this as well, is let's say if we were to multiply this out, so x plus b over 2 times x plus b over 2. Okay. If I factor, or if I multiply this, well, x times x is x squared. X times b over 2 is b over 2x over here. B over 2x. And if I multiply the last one, this is actually b squared divided by 4. Okay. For this, I'm going to have x squared. Well, half of bx and half of bx gives you bx. Right? A half plus a half is a whole. And over here, we can rewrite this. Right? It looks like both terms are being squared. Well, b over 2 squared gives me the last term, the constant term in this trinomial. Okay. All right. On to the last portion of it, so 29, 30, and 31. So at what second was the ball thrown? So over here we have time and we have height. So when it hits the ground, that is when it's being thrown. So when it's being thrown over here, looks like it's in between, directly in between 0 and 10. So for here, this would be 5. That is when it was thrown. At what max height, what is the max height of the ball? Looks at this. If I look on the y-axis, that is a positive 10, so 10, and this is in feet. When did the ball reach its max height? Well, time over here, so I'm comparing here and looking down here. It's in between 10 and 20, so it reached it at 15 seconds. If I threw a ball, it's staying in the long air for a long time, and it is at its height, max height at 10 feet in 15 seconds. When did the ball land on the ground? Well, that's right over here. Okay, so when I'm looking for time, this is 25. Make sure you're clarifying what unit, that unit being seconds here. Okay, how many solutions does the quadratic have? It has 1 and 2. So 2 solutions. What are the 0 slash solutions? So it should be x equal to. Over here, it should be x equal to negative 1. And over here, looks like it's going to be x equal to, I believe it's a negative or a positive 7. Okay, what is the coordinate of the vertex? It is right over here. And that is 1, 2, 3. It's 3 to the right. And looks like negative 8 down. Okay, is the vertex a minimum or maximum? Well, the minimum means it's the very bottom of the parabola. So this is, it's very bottom, so this is a minimum vertex. Over here, is A in a quadratic equation, in standard form, is it greater than 0 or less than 0? If it's greater than 0, it's positive. And if it is positive, that means it is facing up. So this A is greater than 0. If it were facing down, so if it were like this, A would actually be less than 0. The way that I remember is that if it's positive, well, that's like a happy person. If it's negative, sad. Okay, alright, that's it for this. Let me know if you have any questions. Bye.